Hey, welcome to your favorite intermediate algebra class. Today we're going to use some scatter plots and correlations, and we're going to approximate some best fitting lines. So let's look at these scatter plots here, which are just a graph of ordered pairs that are used to determine whether there's a relationship or not between the paired data. Okay, now the first one here is showing you a positive correlation. With a positive correlation, it's again a relationship between paired data that as x increases, y also tends to increase. You notice as we go, x is getting larger, you notice your y is getting larger, and there's a correlation there. They all kind of follow this, they'll follow that kind of a best fitting line. They're kind of around that, if you will. Okay, let's look at the next one here, negative correlation. Now in this case, as your x increases, what's your y values doing? Well, they're getting lower and lower and lower. They're going down, aren't they? And you can see that they're kind of around that line of best fit there. There's sort of a relationship there. Okay. So as x increases, y in that case tends to decrease. And over here you see that there's no correlation. There's no real line of best fit that you can kind of draw around those. So again, there's just no correlation there, is the best way to say it. All right, let's see here. Let's describe the correlation show. Let's say we have, if we looked at the number of MP3s sold in our country compared to the CDs sold, what would you think would happen? Well, it's the number of MP3s sold. If you were to plot this data, right, it probably looks something like that. As the amount of MP3s sold went up, the amount of CDs sold would go down. Okay, so you have a negative correlation here. Negative correlation. Okay, negative correlation. All right, how about your years of education compared to, let's say, your lifetime earnings? Okay, so let's say we plotted a bunch of this data, okay, and it looks something like that. Okay, well, as your years of education went up, your lifetime earnings typically go up. Okay, so you kind of have that positive correlation there, if you will. There's a positive correlation between the two. Okay, and finally, let's look at how about height to IQ. Is there any correlation between the height of a person and their IQ? I say, of course not. All right, that's silly. So that's no correlation there. So this is no correlation. All right, let's do an example here where we actually have some data. Okay, so to approximate a best fitting line for a bunch of data, this is a graphical approach. You go ahead and you draw the scatter plot. You sketch a line that seems to best fit the data, like I was doing, and then you just choose 2 points and write the equation for that. Okay, so let's take a look here at this example. We got the speed of a car during a 30-second interval. Okay, so t is your input, your time in seconds. Y is your miles per hour. Okay, that's the relations here. Okay, so obviously at time t being 0, you're at 0 miles per hour right before you started. 5 seconds later, you're 15 miles per hour. Okay, and look at the end of this. At 30 seconds later, you're finally at 65 miles per hour. I guess this is not my 1998 Honda Civic with about 200,000 miles or close to that on it, because I think 30 seconds later, I'm probably still at about 30 miles per hour. But anyways, let's graph some of this data here. We got 0, 0. We got 5, 5 seconds later, we're at 15 miles per hour. 10 seconds later, we're at 23. 15, we're at 38. 20, we're at 45, 25, we're at 60, 30, we're at 65, okay? All right, there's my data. It looks like there's a positive correlation there. Let me draw a line of best fit, and I'm like, that's pretty good. That's pretty good. Now I'm going to choose 2 points that are on this line. How about that one right there? That was 20, 45, and let's go with our 0, 0 here. Okay, so I choose 2 points now. So I draw this line, I choose a couple of points here. Write those down. So I got 0, 0, and 20, 45. So I'm at step 3, choose 2 points. Well, now we just use those 2 points to write an equation for this line. So as you recall from before, if you got 2 points, you can now find a slope. So y2 minus y1 over x2 minus x1. So we got 45 over 20, which then you punch that in, you should get, what, 2.25? Okay, now we have a slope. So we are now going to use point slope formula. Okay, so choose the 2 points, find the slope. Number 2, now we have a slope and a point, so y minus y1 equals mx minus x1. And I'm going to go ahead and use 0, 0, and our slope of 2.25. Okay, so y minus 0, 2.25, x minus 0, y equals 2.25. Let's distribute that through, but that makes no difference. 2.25x. Okay, that is the line of best fit. And actually, I should say, you notice I'm using t, so I better be consistent with that. 2.25 t, right? T's are time in seconds. Sorry about that. Okay, so there's the equation for the line of best fit. See you guys soon.